RHS Pre-Calculus presents the identity crisis. The goal of this video is to derive the double angle formulas. Jason Bourne has forgotten his identity and has looked to his good friends, Charlie's Angels, to help him get it back.
Using the sum and difference formula of sine, we will derive the double angle formula of sine of 2u. First, we must substitute the a's and b's in the equation for the u's. Next, we combine like terms to come up with the final product being 2 sine u cosine u.
We are now one step closer to cracking the case. Now it's time to find the derivation of supremacy.
Using the sum and difference formula of cosine, we can derive the double angle formula of cosine of 2u. Once again, our first step is to substitute the a's and b's for u's. Then we combine like terms to get cosine squared of u minus sine squared of u. This is the first of 3 identities for cosine of 2u. To find the others, we use the Pythagorean identities. We can substitute 1 minus cosine squared of u for sine squared of u, which can then be simplified to 2 cosine squared of u minus 1, which is our second identity of cosine of 2u. Going back to our first identity that we found, we can substitute 1 minus sine squared of u for cosine squared of u, which then simplifies to 1 minus 2 sine squared of u.
Thanks, Angels. Now Jason only needs one more identity to solve the mystery of his past. Jason will now face the final ultimatum.
Now we will look at the sum and difference formula of tangent to derive the double angle formula of tangent of 2u. Again, we substitute all a's and b's for u's. Then we collect like terms to get 2 tangent of u over 1 minus tangent squared of u.
Thanks to these lovely ladies, Jason Bourne has now found his true identity. Using the rediscovered double angle formulas, we will now do an example problem. Given that cosine of u is 5/13, where angle u is greater than 3 pi over 2 and less than 2 pi, we can solve for cosine of 2u, sine of 2u, and tangent of 2u.
5/13 is equal to x over r, so then we need to solve for y. To do this, we use the Pythagorean theorem. We say that 5 squared plus y squared equals 13 squared, which then simplifies to 25 plus y squared equals 169. Then we subtract 25 over and you're left with y squared equals 144, so therefore y equals 12.
Because angle u is between 3 pi over 2 and 2 pi, the point must be in quadrant 4, making y a negative number. So y equals negative 12. Then we plot the point 5, negative 12, and complete the triangle.
Using the triangle, we find that sine of u equals negative 12/13 and tangent of u equals negative 12/5. To find sine 2u, we use our identity to replace sine 2u with 2 sine u cosine u. We then plug in our sine u and cosine u found before using the triangle. Then we get 2 multiplied by negative 12/13 multiplied by 5/13, which then simplifies to negative 120 over 169.
To find cosine of 2u, we use one of our 3 identities to replace cosine 2u. We will use 2 cosine squared u minus 1 as found before. Substituting cosine u with 5/13, we get 2 5/13 squared minus 1, which can then be simplified to negative 119 over 169.
Next, to find tangent of 2u, we use our double angle identity of 2 tangent u over 1 minus tangent squared of u. Replacing all tangent u's with negative 12/5, we get 2 times negative 12/5 over 1 minus negative 12/5 squared, which is simplified to negative 24/5 over 1 minus 144 over 25, equaling 120 over 119.
We have now completed the practice problem, and you, like Jason, should have a full understanding of the double angle formulas.